I'm going to talk about some future stuff, and then we'll get into exam prep for the rest of class. So you know you have a summer packet. It's sent out to you July 15th. It's required if you're going on to math with me, like you're going on to pre-calculus. So if you're going to take a college class, then you wouldn't have the same summer packet. It would just be whatever requirements the college recommends, which is probably not anything. I will post shortly, like maybe this week, a Khan Academy Get Ready For Pre-Calculus assignment that is not required. So the Khan Academy, where am I? Not required, but it's something you could start now, like knock it out of the way before. There'll be maybe some extra credit or something that comes from it. So it is worthy unto itself, but there may be like an incentive. I don't know exactly what that'll be. Something that comes next year. So it's a short thing, and by short I mean, you should go into it for several days and work on it for a little bit, and then I think it'll be okay. Like, it's not just so short, you could do it in 1 30-second or 30-minute time period, but it covers a lot of stuff, and will just show you how much you're ready for pre-calculus or not. There are some things like sine and cosine that we haven't done that you wouldn't be required to do. So if you get on something and you're like, wait, we didn't do that this year, then you can just email me and I can say, disregard that part. Again, it's not graded, so you're doing this for your own benefit. That's what Khan Academy is. But the July 15th one is required. Just want to put that out there. Also, having completed Algebra 2 honors, yay, y'all can apply for Mu Alpha Theta. If you would like to be in the Math National Honor Society, there are 2 requirements that are national math requirements, not my requirements. One, that you have a 3.0 GPA overall, and then 3.5 math GPA. So those are unweighted grades, just regular GPA grades for those. What? So 3.5, so 3 is a B, right? B plus. I'll have to look that up. Y'all haven't played with your GPAs with Mrs. DeCamp at all? Oh, y'all should. Yeah, you did it last year. Talking about for this year. So a 4 would be a 98 to 100, right? So a 3 would be a B plus, and so it's somewhere between a B plus and a minus. So I can play with that and email you when I post this. But I'm going to post that application now because in the summer we're doing a first ever summer math camp for new students to Epiphany. So students who came from some other school, they're joining Epiphany, and we want to make sure that they're ready to be in class with you guys because they may have had weird COVID experiences somewhere else. So we're going to bring them in, make sure that they covered all the things that they need to cover for the class that they're in so that they won't start the year behind. That's really going to be important for them. And so students can earn some of their service hours before school even starts. And I don't want to leave y'all out. So if you want to be part of the society, then you could go ahead and be in it. So I'll open this up for application now, and then I'll open it up again at the beginning of school. If you join as a now sophomore, rising junior, for 2 years, the requirement is 10 hours of service each year. If you didn't join next year, but you joined as a senior, you'd have 15 hours of service in the 1 year. So it is better to go ahead and join each year, but I think it's important for seniors that they try to get as many hours as the other students because everybody's trying to earn that cord. Okay, so you could join the society and be a part of it but not do a whole lot, and then in that case you wouldn't earn a cord. But if you get your 10 hours of service every year, 15 as a senior only, you would earn our pretty cord, which is blue and yellow tied together. It's a really pretty cord. Questions about either of those 2 things? A minus. So A minus is the average or the, okay, so 3.5 is an A minus, and that's for both courses that you've taken in high school. So your average of geometry and Algebra 2. If you really want to be a member of it, I said weighted, not weighted, but maybe I can do weighted. We'll see. Just talk to me and I can look back up those specific requirements. I was just looking at it quickly in an overview. So there you go. Your math exam does have an essay. It's either going to be one of these two, not both, and you choose, but one of the two. Okay, but I'm pretty much telling you what it is, so study both of these. The first is comparing exponential versus logarithm functions graphically, as far as points that they have in common, like we're talking about the domain, range, starting point, asymptote, how they're similar and different, but talking about all those things, comparing and contrasting them. You had not an essay, but a very mathematical question on your last test, right? It was like that on the last page where you could graph on a calculator and go from there. So similar to that, except essay form. So you're going to say to me things about how, since the starting point switched the x and y values, that's one of the ways that it shows they're inverses of each other. Inverses undo each other. I don't know what you want to say in your essay, but it's about 5 points, I think, so it's not a deal breaker, but it is explained two important functions to me, and there's also a graph. So you want to find 5 things to tell me, and your graph needs to be right. Sound okay? Okay. Second one, polynomial discussion. So this would be like your project. So thank you, Sarah, for this. This on top. So this would be like your polynomial project. Zeros, x-intercept, y-intercept, end behavior, degree, synthetic division. If I gave you, like this project, we gave you the x values, right? You had to come up with a polynomial on your own. What if you were given the polynomial here? And 1, 0. Could you find the other zeros with synthetic division? So if I told you one of them is 2, I told you one of them is 2, could you set up synthetic division that said 2, and then I forgot the rest of this. It's like 2, what else? No. 3 and 8. So if you use synthetic division to find out that this had 0 at the end, and then you can factor from there. We can actually do this example in a minute. For those of you on the video, we're looking at this. It's so big I can't show it to you, but I might try to take a picture of it. But look at your own project. Some of them from what got hung. We talked about this the other day. When they got taken down, I don't know where they went. So there's a couple up here if you want yours back. If not, they're in Google Classroom like your rough draft. So you have a project to look at if you wanted, if you were unsure. So looking back at this, if we were told that the polynomial was 2x cubed plus 3x squared minus 18x plus 8, then if we're told that 2 is a 0, we could use it in synthetic division. How do we finish this out? What happens next? We don't put 1 here. What do we put? 2. Yep, to bring the 2 down. And then, okay, multiply. So that's 4. That gives us 7. Multiply again. Add. Negative 4, important because this makes negative 8, which makes the 0, which is yay, it worked. So that means that we have x minus 2 is a factor, and this changes into a factor. How do we make that a factor? And then that actually factors again. You can find the other zeros without looking at the project. We could say this is a trinomial. It factors as 2 binomials. 2x squared looks like it's going to be hard, but that's actually easy. Can you see how to get 7? 2 times what makes 8? So that's 4 minus 1 makes 7. 8 minus 1 is 7. That works. And that gives us 3 zeros. 2, a half, and negative 4. So given the polynomial and a 0, could you come up with the rest of the zeros? Sure you could. You could talk about in behavior for this. You could talk about degree. What's the degree? So I got a 2 and a 3. Both are important things. Which one's degree? So this is degree 3. What is 2? Leading coefficient. So leading coefficient of 2, that tells us together that our in behavior is this, because it's positive 2, right? So you can tell me Saturday Night Fever, or you could tell me, because that's Mr. Wang, if he was looking at your exam, would have no idea what that means, but you can say one end goes up and one end goes down. That's what, you can write Saturday Night Fever, but you might want to end it with a little picture like, my essay does not need to be grammatically, try to be I can't even say it, grammatically correct. Use sentences, but insert some notation if you would like. That's perfectly fine. This is your math essay, and I accept that. So if you say Saturday Night Fever, maybe just follow it with this picture, okay? Because that would be helpful. So how many zeros does it have if it's a third degree polynomial? How many zeros? How many times will it cross the x-axis? 3 at most, maybe 1. But at most, it could cross 1, 2, 3. It definitely can't cross 4 or 5 times. This tells you that x-intercepts, the max number is 3. Like, there's so much stuff I could come up with and talk about. It's a polynomial. I could say that. I could say it has 4 terms. The constant is 8. Like, there's all kind of math stuff that I could write that would make it seem like a really long essay. It's 5 points. I don't need you to make it a really long essay. I'm looking for at least 5 good things that I could think about and go, good job. What was the question? No? Okay. Thought I heard some. Maybe the fridge. So there's a lot of stuff to talk about here. There's a lot of stuff to talk about here. Any questions about what I mean? Again, not a deal breaker. 5 points. Write me some good stuff. Yes? Which means find the zeros, plot those, connect them, but not perfection, just like a sketch. So don't let this stress you out, okay? I know you could find good things to say about either one of these things. But I'll post this so you have it for reference if your notes right here are sketchy. Questions here? All right. Then I gave you something good. I don't know where it is. Hold on. Also, just a quick reference for your exam. Your exam kind of looks like this. Obviously, it's not going to say Hutch's name, somebody else's name, but in the front, it'll be this. If you take it off to bubble in, ask for a stapler and staple it back to the top, okay? Because the back side is going to be the essay, so I can grade the front and the back. Easy peasy, post grades. You'd like to see them as soon as possible. Note how this is weird. See how it's bigger? You see it in the back? So these are regular multiple choice, and then this is a group of matching. So this looks sort of like one question where you're going to match things. So like a graph and a description of it. So you're matching, and so in this group, one of them will be an A, and another one will be a B. There's 6 questions and 6 choices. All right, I just wanted to show that so you didn't think it was completely weird. So still bubble it in, but it's matching. Okay. So there's that. All right, this may be in a different order, but here we go. Linear function, things that I'm thinking about. And I'm going to post this and the one that has some of your stuff as well. So if I go too quickly, know that this is posted and recorded. You can go watch it again. So linear function, things that I'm thinking about are, this is what a line looks like, mx plus b. I know that m is slope and b is y-intercept. I know that y equals a horizontal, x equals a vertical. I know the slope of horizontal is 0 and the slope of vertical is undefined. I know that x and y-intercepts have zeros in the point, like number slash comma 0 or 0 comma the other number, lines. I could say lots of other things, okay? We did a whole page on this on our one-pagers for a different class. I don't think y'all think we're still doing note cards at this point, but I could talk about point slope form. I could talk about I could actually graph some stuff. I could talk about increasing or decreasing. There's so many things I could talk about, but this is a nice little summary, which is all I'm looking for in this page. Some big things to remember. All right. Then these two boxes kind of go together. I have odd degree polynomials. That means that the degree is odd. It doesn't mean I'm looking for an odd number anywhere. It means that the degree has to be odd, right? The 2 and the 2, they don't mean it's odd, just the degree. And if it's odd, it either has Saturday night in behavior in either direction. This one has a leading coefficient that's negative. This one has a leading coefficient that's positive. It tells me about in behavior and notation like as x, there we go. I'll just write it. As x goes to infinity, y goes to infinity. Like that would go with this guy. And then as x goes to negative infinity, y goes to negative infinity. So that in behavior notation we did. Whereas even degree polynomials, if they're even and they have a positive leading coefficient, so positive here, it goes up. And if it's negative in the front, the leading coefficient, and it's got an even number or negative with an even, the ends go down. My chart's not that great because the even degree and the even roots, they don't match up, but that's what this arrow means. I was trying to kind of connect those because that is a little bit helpful, but we'll get to that in a second. So the first row, how about that? Overview, makes sense? Again, this will be posted if I'm moving too quick. Theoretically, you're just adding some other things that you missed, not necessarily doing the whole thing. So it'll be posted if you want to go look at it in exact slower format. Quadratic function. So a quadratic function has degree 2, has an x squared. Specifically, not just even, but degree 2. And if that's true, that negative b over 2a will tell you the x value of the vertex and the line of symmetry. The vertical x equals line of symmetry. A quadratic function can also take on the form of intercept form or, vertex form, where we can pick out h and k as a vertex. This is vertical flip, stretch, and moving stuff around. So here, hk is the vertex. Theoretically, you have note cards about that. With that, I'm just going to skip down here because they go together, the quadratic formula. That tells us solutions. So it actually says x equals. That will tell you solutions. If you were unable to factor it, but it was a quadratic, you could definitely find the solutions. If you use the standard form to get your A and your B and your C out, note how negative b over 2a is right out front of this formula. So if you can write down the quadratic formula, it will help you remember this as well. The discriminant is the part that I've underlined. If it's negative, then your answer is imaginary. Remember when we did that? Because it would be plus or minus imaginary. Imaginary numbers are not on this sheet. I just made a note to myself at the top. I'm going to post that. You might want to make a note to yourself. This didn't practice imaginary numbers. Maybe that would be something to review as well. Okay, quadratic formula. Do y'all remember that? Got the people in your head going 2A, 2A? All right. Good answer. Okay, so here we go. Even root function and odd root function. Roots meaning they have a square root or a cube root. Even roots have a limited domain. They start here at 0, 0 unless they've been shifted, and they don't go into negative territory because of imaginary numbers. Odd root functions have all real numbers because you can do these things. You can do this, the cube root of negative 8, 8, and 0. Sorry, I was talking and I forgot to put it in there. So odd root functions have domain of all real numbers, whereas square root function has a limited domain. Those are the players that can play. Remember I was talking about that? So you want to have a general idea of what those graphs look like, because then you can pick them out. If you have graphs in, Thomas, you with us? If you have graphs in multiple choice, how can you tell the difference between graphs? What can you do if you're not sure? Wait, they all kind of look the same. Some of them look like this, and some of them look like this. They're so similar. They both go up on the ends. What do I do? What can you do? Just make an XY chart, okay? If they give you an equation, plug in a number. Plug in 0. If you get a value out, circle the ones that are choices that are left, and then try something else. Plug in 2, see what you get. So you can test values. You should never just guess. It's not about you being able to guess. It's about you being able to actually find the equation by checking things along the way. So you can definitely check your equations to see what works. Because multiple choice, you're not going to graph, right? You're going to choose from graphs that are listed. Or you're going to choose the equation from the graph that's listed. So these guys, good? Then we went to exponential and logarithmic. They are both equations that we've done recently. We talked about on the essay how you'd want to compare them. So they would reflect over the y equals x line, but you should be able to say these 4 things: the domain and how they're different, the range and how they're different, and also the same because they switch, right? X equals or y equals, the asymptote, the starting point, 0, 1, or 1, 0. So it's up to you. You can memorize both, or you can memorize one and know that the other one is switched. Eventually, you'll get the other one in your head if you at least memorize one of them. So I didn't plot any points. These are just general graphs just to help me remember which one has the horizontal asymptote and which one has a vertical asymptote. Any questions so far? All right. Systems of equations. This isn't the emphasis of our test right here, but we did do this year, and I need you to know it for future stuff. So you might have a question that has you solve a system of equations. And we did that 2 ways. We either did substitution, where you had something obvious. This is a line that has slope. This is a horizontal line. But those 2 lines would cross somewhere. So horizontal line, line with slope, they cross somewhere right here, and you have to find out what that is. But you don't have to graph it. You could substitute in. Do you see how if we put 3 here, x has to be 1? It's the only thing that works. They only cross in one point. The other choice we have is if we have 2 equations, we could graph them. We could also do elimination, which means we're trying to get either the x or the y to cancel. When I worked this with my last class, they said, let's multiply the second one by -3, and so that they canceled. I'm not going to give you something so gnarly. I made this up on the fly earlier. And then you would plug that back in to get y. This being an exam and you have a lot of questions, I'm not going to do that. I'm just going to give you something that you could plug in and figure out. Okay? Bless you. But y'all remember elimination? That was actually kind of fun. You multiplied, you canceled. Okay. Absolute value graph, we've already seen this notation where we have plus or minus and a, change in horizontal direction, opposite math, change in vertical direction, real math. It looks like a V, absolute value. If you can't remember this formula, that's fine. What do? You just make an XY chart and you test some values. Totally within your realm of stuff, but it's good to see absolute value and think V so that you have an idea of what's supposed to happen. That A value still gives you stretch, but with this linear form, it also is slope. Okay, my first page, I don't have, so I'm going to add here imaginary numbers. Square root of -1 is imaginary. That means if we had x squared equals -4, to solve that, how do we undo the square? Square root, what else? Two and just I. But what else? Before I even figure out how this simplifies, what else? Plus or minus. So the x squared, okay? it needs to say to you up here, I put it somewhere I thought. Oh, it was on my other page with the essay. When you see this degree, it means 2 solutions. So if you only write one down, you're shortchanging the problem. So then we're going to have 2 answers. We're going to have plus or minus. The square root of 4 is 2. The square root of negative 1 is I. You get 2I. It's not the square root of I, it's I. And that lets you solve mathematically any quadratic. We did things like multiply. So do you remember if we said 2I times 1 plus 3I? How does that work? That's distributive property. What do? 2I plus 6I squared, which is 2I minus 6. So I squared is negative 1. Do you need to show all that work? No. Do you need to understand I squared is negative 1? Yes. So, imaginary numbers. Don't forget those. Other side. Here we go. Here's the top. This may not be in exact same order as yours. If not, I apologize. Like Kramer's rule is not on this one. So, we'll have to add that. Solve rational equations. This particular example, it's rational because it has fractions. I don't remember which class I did this in last week, but we multiplied both sides by 42 so that it didn't have a fraction anymore. That's as far as we got in rational equations. We didn't do any more. We graphed them in our class, but we didn't do any more solving than this. Okay, this would be, we did that earlier in the year when we learned how to just make equations simpler. Systems of equations I did on the other page. Circles and distance is not something we did. That's something we'll do next year. So you can ignore that. Variation. Why do I have not equal to? So variation. The word variation means to vary, right? So it's not equal to. So it's not equal to. It means it's equal to something with x except there's some constant of variation. That's where I said you get $1 for allowance and your sibling gets $2. You get 4, they get $8. They always get twice as much. So you don't get equal allowance. It's not equal to. It's equal to some constant variation. The parent function is y equals x, but that's not variation. So, I mean, I guess that could be 1, but that would be equal. But that we don't try to throw in the exceptions. So, inverse variation. We did that quickly before we did rational functions. What's inverse variation? Inverse. So y equals a over x. So as x gets bigger, y gets smaller. In this case, they both get big. If you get more allowance, they get more allowance. But in this equation, as one gets bigger, the other gets smaller because we're dividing by x. So that's different. And then joint variation would be them multiplied together. But I probably would just go to these two. So this is called direct, and this is called inverse. Synthetic division, we just did that. Long division, we did a lot with rational functions, so I don't have an example here. If time, maybe we could go back to that. Solve radical equations. If it has a cube root here, we cube root it by cubing both sides. So you can see in pink, I cube both sides. That cancels the radical. X plus 3 equals 8, x equals 5. If it's even, make sure it doesn't break it when you plug it back in. Check for those extraneous solutions. This one was a little bit more complicated, but the same idea. If it is to the 2/3 power, you raise it to the 3/2. You flip it over. This is also flipped over. This is the 1/3 power to the 1/3. So we cube both sides. Then you actually have to do this correctly. Make sure you do the root first. Maybe you need to write it as the square root of 16 cubed. to remind yourself to do the root first. And that would be 64. Composition of functions. Instead of just putting in 1 or 2 into the g of whatever number, you're actually sticking a whole function in. So we had that on a test. I believe it was chapter 6. Might have been chapter 6. You might want to go back and look at that. That was before inverses. You're putting a whole function in into the other function. So practice that because that confused some of you. Some of you tried to make it multiplication. It's not multiplication. Multiplication. It's inside. It's subbing inside. Function inverses. I made a list. Functions are supposed to undo. That's their purpose. The x and y switch. They reflect when you graph them. So this is the graph. This is the notation. Do you remember this notation? So if it says find f negative 1, that means find the inverse. I need you to know what that means. Asymptotes are boundaries of the graph. So you need to know, I mean, we've had to find them. We should know what they are. This page doesn't have, so yours might, so this is not necessarily in your order. We have, let's go back to yours. Here's yours, a blank one. Define asymptote. We know more stuff now, especially with rational equations. So rational equations have 4 kinds of asymptotes. What's one of them? What? Like really loud because you're way back there and this fridge is on. Horizontal. So we have 2 of those. So we have y equals a number and y equals 0. Both of those are horizontal asymptotes. What's the rule for y equals a number? Like 2 or 1/2. Where do we get that from? The degree on the top and the degree of the bottom is the same. That's important. Y equals 0, what's happening with the degree? The degree is larger where? On the bottom. So if we're looking at x over x to the 5th power, definitely y equals 0. Yes. 3, there's another y equals asymptote that's not horizontal. What is that? Slant. So y equals mx plus b. And that happens when? Top bigger by 1 degree, and we use long division. We disregard the remainder. There's one more kind of asymptote. What is that? X equals, where does that come from? Denominator 0. Where, when, how about x value? X value, where, denominator equals 0. So you just take the denominator, you set it equal to 0 and solve it. And when you get x equals 2, you're done. That is it, x equals 2. Or whatever it is. So there's 4 of them. You can only have this one and one of these guys in the stuff that we do. So this one and one of these. Do you have to have a vertical asymptote? The denominator doesn't equal 0, there's not one. So if you have x squared plus 4, there's no x you can put in that would be 0, so you wouldn't have one. Okay, we talked about function inverses on the other page. Exponent rules, this is stuff like 2 to the negative 1 is 1/2, and that needs to come right out, like in your mind, and you need to know that rule so good, there's no question about it. How about 2 to the 1/2? What's that mean? We're not solving it, it just is. How do I rewrite that another way? Yeah, so it didn't have really a number answer, it's the square root of 2, sorry. Notation-wise, it means the square root of 2. So numbers on the bottom mean roots. Adding, subtracting, multiplying, all that stuff you need to know. And they go with these logarithm properties. So if we said x squared times x cubed, we would get x to the 5th. And over here, if we said log of x plus log of x, we would get log of x squared. So addition, right? 2 plus 3. Addition goes with addition, it goes with multiplication and multiplication. Like these are similar rules because logarithms are exponents. So all the logarithm properties, log of a plus 1/2. Oh, I'm going to put a minus there. Actually, I'm going to put a minus here. Plus 1/2 log b. What does that mean? If I combine it, there's a fraction. What goes in the top? The square root of b. This means an exponent. So square root of b or b to the 1/2. I don't care. Either's the same. They both mean the same thing. So either's good. And on the bottom is a because it has a negative. It doesn't matter that it's first. First things don't go in the top. Negative exponents go in the top. This is like saying a to the negative 1. And a to the negative 1 means a in the bottom because this number is an exponent. I'm going to erase that for confusion's sake. Factor and factoring. A factor is the small unit that multiplies to make a bigger unit. And I've made this little factor tree, greatest common factor, 2, 3, and 4. These are special. You should remember difference of square and SOAP. This is a trinomial, and this is grouping. But always do greatest common factor first. And somewhere, I have this stuff. Kramer's rule. Y equal, oopsies, I don't want that. 2x plus 3y equals 7. X plus y equals negative 4. Kramer's rule says that x equals 2 matrices. Do you remember how to do it? What goes? I didn't leave enough space. Sorry. So I write not x. I skip it. I write 7 and negative 4, 3 and 1. And on the bottom, I put this, 2, 1, 3, 1. I don't know why it's showing up so weirdly. There you go, better. To do determinants, you multiply this way first. So you would get 7. Then you subtract the other way, negative 12. You would get 19. And on the bottom, 2 minus 3 equals negative 1. X equals negative 19. So you replace the column of the one you're looking for. X is the first column. Matrix operations are like adding them together or multiplying by